Okay, this is video 3B. We're going to pick up with information for quiz 3. Wanted to first tell you about the calendar. This tells the day of the year for each day in a consecutive order, so you can, for purposes of calculating interest. So as an example, suppose we wanted to know from April 18th to November 11th. So I look on the sheet, and it tells me that April 18th is the 108th day of the year. November 11th is the 315th day of the year. Before I go any further, I want to tell you we're not going to be involved, I don't think, unless it states leap year, don't consider it. It has to specifically tell you it's a leap year, because obviously on this table there's no February 29th. So February 29th is the 59th day of the year, or 28th, excuse me. February 29th would be the 60th day of the year, which means March 1st would have to move back one, and every day after that. So unfortunately, but we won't be bothered with that. So by the way, this goes in 1 year, and we've already skipped February, so we don't have to worry about it. So we just subtract. So if we were doing a loan that was initiated on April 18th and matured on November 11th, the length of the loan would be 207. And if you're counting interest, you still divide by 360. And I'll tell you real quick why that is. Because which of those two fractions is larger? Well, the larger one's the one with the smaller denominator. So see, this gives you a larger number. So the banks make out. That's how it goes. That's the rule. All right, June 14th to January 21st, 4th. So for this one, we turn the corner. But still, you will still want to know the days of the year. So June 14th is 165th day of the year. Of course, January 24th is the 24th day of the year. So in this one, I just have to figure out how many days are left in the first year. Now, you have to count that day. So when you subtract from 365, and then you add the 24. So it's 224 days from June 14th to January 24th. Now, on the other hand, if you don't know the days, then you just may know the length of the loan. So let's say the loan was taken out on July 4th. For 150 days. So you just find the number for July 4th. You add the 150, and you get 335. Well, the 335th day of the year happens to be December 1. So December 1st, loan would go from July 4th to December 1st. And that would be 150 days. So you get the idea? So I'll be sending you this. So when we calculate loans and there's days involved, we know what to do with them. Okay, so let me erase. So we want to use simple interest formula to solve the following problem. Aiden borrowed $6,000 for 30 months from a bank to repair his car lift. So that's the principal. So notice I wrote T as 30 months. I didn't write T equals 30 because if I wrote T equals 30, it would be assumed to be 30 years. But I wanted to change it to years, so it's 30 over 12 years, which is, it's a 6. So it's 2.5 years. Common factor is 6. So 30 months, 2.5 years. When you see and you hear it, it makes sense. So the interest rate's 5.75%. How much did Aaron pay, or Aiden pay to the bank for the use of the money? So this is a simple loan. There's no compound interest. We're going to get into that in the next video. This is just simple. So they're charging him interest for the time used, but there's no compounding. They only charge him the interest once at the end of the 30 months. So the interest is PRT. So that's 6,000 times 0.0575 times 2.5, right? 2.5. So the interest will be, rounded to the nearest penny, $862.50. Remember, once again, when you get your final answer, that's when you put your dollar sign. You don't need to do it here; it's too busy. So determine the amount he repaid the bank on the due date. Well, that's pretty simple. By the way, the total amount due is the accumulated value or the future value. So A, if you look on your formula sheet, A is called the accumulation or the future value. So A equals P plus I. So it's 6,000 plus 862.50. So he owes the bank $6,862.50. He owes the principal that he borrowed plus the interest that accrued for the time that he had the loan. So that's his payment. Now, in real life, you're not going to have this kind of a loan unless it's a personal loan, like somebody, father to a son or uncle to a niece. But that's atypical. Later on, we're going to see how banks have monthly payments, monthly installment. That's something we're going to get into. But this is just for simple loans. Now, there is one other type of loan that I got to tell you about, and that's called a discount note. A discount note is a loan where you pay the amount of interest up front. It's subtracted from the principal. So the accumulated value is equal to the principal is equal to the future value minus the interest. Now, in real life, they stop companies from giving these kinds of loans because the advertised interest is unfair. It's not really true what they advertise. But you will find these in government bonds, and they work in reverse. It's not something that you loan, it's something that you buy. The bank sells them to you, you buy them, and you buy them at a discounted rate. So, for instance, if you bought a $10,000 note, you would get it, say, for $500 off. You get it for $9,500. You would save $500. So when it became mature, you would get $10,000 back. But you see, the interest is on the $95 that you paid. So it's a little bit more than it looks like 5%. Okay? Anyway, let's keep this discount note in terms of a regular loan, but it's a discount loan. See how it works. So Julie borrowed $36.50. For 18 months. So I just went ahead and changed it to 1.5 years. 18 months is 1.5 years. and it's a 7.6 discount note. So how much interest is Julie going to be charged? Well, that's still the same formula, I equals PRT. So the interest will be P times R times T. PRT. So the interest, rounded off to the nearest penny, is $416.10. Now, instead of taking the 3650 and paying that plus the interest back at the end of the year and a half, the discount says you'll subtract this from the P, and that's what you take home. And then when at the end of a year and a half, you pay the P back. It's just discounted. You're taking the interest off beforehand. So it's a little unfair when you're taking a loan. When it works the other way, it's to the disadvantage of the government, and then who cares, right? So how much did she receive from the bank? So the amount she received would be the 3650 minus the 416.10. So she actually walks out of the bank with $3,233.90. That's the actual loan. It's a discount loan. It's discounted. So that's how much she actually borrowed. So what she pays back, she pays this plus this, which is the original principal. So it's kind of backwards. See here, we took the full amount, $6,000, in accrued interest, and we paid what we borrowed plus the interest back. Here, we take the interest off first. So we only borrow this amount, which is less than the actual principal. But when we pay the total back, the interest plus what we borrowed, it's the total principal. So it's discounted. I think they prohibited finance companies and banks from doing these kind of loans because they're kind of controversial. They're hard to understand for some people. So the question we have is, what's the actual rate of interest? Well, the actual rate of interest, you just use the simple interest formula. So I'll do it up. See, I guess I could do it down here. So the interest, I equals PRT, we got to solve for R, because this R is not really true. You'll see what I mean, because this is the interest. The principal, the actual money she took home, that's her actual principal. That's what goes here for P. R is, we're not sure what R is. That's what we're trying to solve. And T is still 1.5. You see, we can't put the 3650 here because that's not the true principal. That's not what she walked home with. So when you work this out, when you divide both sides by 3233.9 times 1.5, this cancels, obviously. You have R. And when you work that out, you see that R is equal to 0.085778. And as a percent, that's 8.5, we'll call that 8.58%, which is a lot higher than the advertised rate. Because the interest actually came off of this, not this. I mean, we calculated off of this, but as a discount note, the truth in lending, if you will, is this is the actual percent, 8.58%. That's one of the reasons that discount notes aren't very popular and they aren't allowed in the main. Okay, one more topic here. What we're going to talk about lastly is a simple interest loan where there's a partial payment. Partway through, we're going to make a partial payment. So we have to readjust. It's a precursor to monthly payments, but those are structured and they're regular. This could be irregular. It's just, you know, you had some extra cash and you decided to go in and pay off the loan, part of the loan early, to save some interest, essentially. Remember, because the bank can only charge you interest for as long as you have the money. Once you pay it back, they can't charge you interest. So sometimes people want to pay things off early. So let's say we want to borrow $2,400. And it's 5.5%. The effective date is February 1st. So that's the date of the loan. That's when it becomes effective. There's a partial payment of $1,000. And that occurs on May 1st. The maturity date is August 31st. So we want to know the final payment. That's the big question, the final payment. Okay, so the first thing I like to do with these is to get the numbers for the days. So I look it up. February 1st is day 32. And it says right up here, not a leap year, so out of the question. May 1st is 121. And August 31st is 243. So those are the days of the year. So that helps me because I'm going to have to figure out how much interest was accrued for the first time period. So between February 1st and May 1st, how many days is that? So if you subtract 121 minus 32, you get 89 days. Okay? So while we're at it, let's just do the other one. Between May 1st and August 31st, if you subtract these two, you get 122 days. Okay, so we know the time periods between the two payments. So on May 1st, how much interest do I owe? So I'm going to call it I1. In other words, the first payment. So this is I1, first interest. So that'll be the principal times the rate, which is 0.055, times the time, which is 89, divided by 360. Once again, don't forget, banker's rule, you gotta live with it. So the initial interest, that if you work this out on the calculator, the initial interest is $32.63. I'll just put I1 here so we remember what that is. So that's how much interest I owe on May 1st. But I paid $1,000. So what's my new principal? So this is P1. That's my starting principal. So my new principal will be what I originally borrowed plus the interest minus the payment. It doesn't really matter arithmetically, but the bankers will tell you we always add the interest first before we take a payment. Well, arithmetically or mathematically, it doesn't make a difference. But you can see that it doesn't matter which way I do it, because it's all order of operations are all the same. And so we end up with a new principal of where'd it go? $1,432.63. it's really pretty easy to see, because if I subtract 1,000 first, I get 1,400, and then I add this, I get 1,432.63. So this is P2. So that's how much I owe on this day. The $1,000 minus the interest, I've already paid off. So this is what I could still owe from May 1st to August 31st. So to figure out how much the second interest is, I put in P2. I multiply by the percent, which is still the same, and then I take how much time it is. Well, there's 122 divided by 360. See, it's an annual interest rate, but you can't apply the whole amount because it's got to be tempered by how long you did it. So that's why time, it's annual rate and the time is in years. So they're in conjunction with each other. They work together. So when I do this calculation, I get $26.70. So this is I2. And so if I add those two numbers, that's what my final payment is. Remember, principal plus interest equals future value. So my final payment will be the sum of those two, and when you add them up, you get $1,459.33. So you can real quickly see that how much interest we paid was this plus this. If I could do it in my head, $59.33 is the total interest paid. But it wasn't because it accrued over the total amount. It was first part, and then part of it was the second part. So this is a early payment on a simple loan. Right, so you have enough ammunition between videos 3A and 3B to go ahead and finish quiz 3, which once again is due Friday the 17th. I know you don't know what day it is here, but this is Friday the 10th. Anyway, I mentioned in one video that didn't load, this is from melanoma. I'm not dying, I don't think. But if you think I am, pray for me, and I'll accept your prayers. So, Dr. K out.